Reducing continuous integration, continuous deployment, builds and test time from 50 minutes to 16 minutes, 50 to 16. We're going to explain that. It's the AWS Developers Podcast. Good morning, it's Friday morning. In every good podcast application, you can find the AWS Developers Podcast. Thank you for subscribing, sharing your feedback with us and leaving thumbs ups or little star. Talk about the podcast to your friends, your colleagues as well. This is how we grow the community. Today, I have the pleasure to welcome not only one guest, but two guests. Sharanya Viswanath, Senior Engineering Manager, and Murtaza Javait, your software engineers at Duolingo. I guess most of our listeners know Duolingo. I use Duolingo a lot when I was learning Spanish. But in your words, if you have to define what is Duolingo.
Hi, I'm Sharanya. I've been at Duolingo for 4 years now. In my own words, Duolingo is the most downloaded education app. We have about 40 million daily active users and over 100 million monthly active users.
Wow.
Yeah, it's a lot. And it's a 12-year-old company, and our mission has always stayed the same, is to develop the best education in the world and make it universally available. And so we started as a language learning company, and now we teach over 40 languages, and we also now teach math and music.
Oh, I didn't know that. So
yeah,
Duolingo is not only the language. I can learn
it's not
other
only
things
the
as
language.
well. Mm-hmm.
Scale-wise, you can imagine like every single day, our learners complete several million lessons. So just reflecting just how engaged our community really is and how we ensure that our infrastructure supports all those learners in action.
Yeah, I guess the infrastructure on the back end must be huge. Maybe that would be a good episode for another podcast, another episode later. But today we are talking about CI, CD, continuous integration, continuous deployment. And just a few days ago, I was in the metro in the small city where I live, and I was sitting next to someone that was learning on Duolingo in the morning. And it's so addictive. It's something you can do. You can use this app during your commute in the morning in public transport because the tasks are quite short. There is the gamification aspect as well, where you can earn bonus points or different advantage when you progress in your learning. I said it probably I when I was learning Spanish, I used Duolingo as well at the beginning to learn the basics of Spanish. So let's go back to your continuous integration and continuous deployment. We are not going to define that. We assume that if you're listening to the AWS Developers Podcast, you have some kind of CI pipelines in your company as well. How many apps do you have? Just quote 2, an Android and an iOS one?
Yeah, pretty much. This is Murtaza. I joined the company about 1.5 years ago, and I, joined this team called the Test and Release Infrastructure Team, and we were responsible for dealing with CI/CD pipelines and infrastructure for all of our client apps. So we also have a bunch of backend services. Those have their own CI/CD stuff, but for our client side, it's pretty much iOS and Android that take up the majority of the work. We do also have a web app, but it's generally the effort is towards iOS and Android.
What's the technical stack for you? What is the programming language, the main framework that you're using before disclosing any secrets, of course?
Yeah, so on iOS and Android, we try and use native frameworks as much as possible. So for iOS, we're using Swift and UIKit, and we're using Xcode as our build system. And then on Android, it's Java and Kotlin with Gradle as the build system.
Wow, so it means it's really two different applications, two different code base. You're not using Flutter or React Native or these type of things. It's really two different applications that you need to build. Can you share also the size of your build pipelines? How many builds per day, per month? How many machines? I guess you have two different infrastructure, one for Android because you can probably use Linux for that, and one that was based on Mac for iOS.
Yeah, at Duolingo, like Mert had said, we are mobile first, and we see it reflect on the number of changes that we make to the iOS or Android app. And we typically ship around 200 to 300 PRs weekly in both the client repos.
Wow.
Um, and I'll zone in more on the numbers, especially on iOS, because we are talking more on iOS CI/CD. Um, our typical weekday load is about 30 to 60 M2 machines. We run one build at a time, and we run about like say 3 to 4 CI checks per pull request. So these are the checks that need to pass. When only when they pass, then we say it's ready for it to be merged. And once it's merged, then we run special checks even post merge to validate the code that gets shipped out the door. So bunch of stuff that happens pre-merge, bunch of stuff happens post-merge. And then when we cut for our weekly releases, we also have additional checks that run as part of the CI/CD here.
And that's a manual step, the cut for the release. So we are talking about a continuous integration chain. It's not continuous deployment. You have a manual cut once per week to actually publish the updates on the app stores and the Play Store.
Yes, that's an important distinction, because that's how you have to ship to the App Store. You can't, and both app stores have some sort of review process, and so we do it weekly here.
So you recently migrated to Amazon EC2 Mac, and that's something we are going to talk about. But more generally, you went into a heavy optimization of your pipeline. I said it in introduction, you went from 50-minute build to 16-minute build. So what was the challenge with 50 minutes for a build? It doesn't look too much like that. So what's the challenge you were trying to solve?
I guess it was many-fold. Even before tackling the 50 minutes here, one thing that I wanted to call out is, before AWS even offered any like macOS instances, we had a very distributed setup with multiple providers. So with that setup, we had less control over the instances, be it OS or Xcode upgrade on those machines. And so we wanted to like just consolidate infrastructure to one provider. And we switched to AWS because it was something that we had already used for all other CI at Duolingo. So once when we consolidated and structured our instances, we now have like more control with SSH access and like being able to install like the latest and greatest Xcode, latest and being able to leverage latest hardware. I think this most simple and powerful change is like hardware upgrade, and like that giving us an edge over our build time. And finally, we were also able to auto scale our instances. We were not relying on any like static instances. And we were able to say like, hey, okay, you're idle, you're not having any sort of workload. Now it's ready for you to shut down so that we can, save on costs.
Mm-hmm. Yeah,
so,
that's important as well. So did I understand correctly that the Android builds were done on Linux and they were on AWS, and then you were using another provider for macOS. So you had no shadow IT of Mac Mini racked somewhere under a desk. It was already in the cloud, or at least outside of your environment.
We did have few Mac Minis that were in our office, but we like completely deprecated all of that and you moved things to AWS Cloud.
I forgot to ask you, what is the build orchestrator? Are you using Jenkins or something much more complicated? Yeah. Oh, it's Jenkins.
You're using Jenkins, yes.
And that Jenkins is running also on AWS on EC2 instance, on Linux probably there. There is no need to have a Mac as well. So the challenge was to unify the set of machines, but also to reduce the time of the build. You said 200 to 300 pull requests per week. Did I remember correctly?
Yes.
multiplied by 50 minutes. Yes, that's a lot of build time. How things are different between Android builds and macOS builds? What are the main difference?
So there's a couple of differences in terms of the actual checks that we run. I would say it's relatively similar. Like on both platforms, we're running unit tests and some form of end-to-end tests. On iOS, we also have snapshot tests. The way we structure the jobs is slightly different. On Android, we just have one build that runs on the PR. That is pretty much the only required check that developers have to wait for. And that goes and splits off into a bunch of different parallel tasks. Whereas on iOS, we've structured it as 3 separate builds that happen on 3 separate machines.
So you start to use EC2 Mac a while ago. When I talk with Amazon EC2 Mac customers, usually what they tell me is that they love the fact to have a Mac, but with everything they know from EC2. Like there is machine image, there is security group, there is auto scaling. Is it also the reason why you choose EC2 Mac?
I think all of that is true. I think we had expertise in the company already at working with AWS, and we have a lot of infrastructure built around. All of our infra was pretty much in AWS, so most people were familiar with it and comfortable with it. And so, we have our cloud ops team who are experts in AWS, and we could rely on them to help us with parts of the EC2 Mac setup. I joined the company not knowing anything about AWS and cloud infrastructure in general. So EC2 Macs were actually one of my first exposure to cloud infrastructure in general.
So you had to learn the details of how to build an image and things like that. How many configuration are you maintaining in your CI/CD pipeline? Because typically our customers are building on multiple version of Xcode for multiple version of iOS. So I guess you have like a matrix combination of the platforms you're supporting.
We actually keep it pretty simple. We only have we have one version of Xcode running at any given time. We try to stay up to date. We try to upgrade our CI fleet to the latest version of Xcode within a month or so of when the latest version drops. But we're relatively aggressive about deprecating old versions of iOS when Xcode stops supporting them.
So it's more linked to the version of Xcode, and you align the version of your app, of your release, based on the version of Xcode. What was the challenge you had to integrate EC2 Mac? EC2 Mac is a bit different than EC2. For those of you that never touch EC2 Mac, it's based on dedicated host. You need to acquire a machine for a period of time. It's a minimum of 24 hours. How did you deal with these constraints?
There were definitely a lot of challenges and a lot of learnings that we had along the way when integrating the EC2 Macs. So initially, our old setup back when we had our old cloud provider, we would basically provision a certain number of machines, and that was what we had. If we needed to add machines because of extra load, like for example, we talked about our weekly release cut. One of the things that kind of drives the test and release infrastructure setup at Duolingo specifically is that weekly release cycle. A lot of PRs are going to be merged near the release cut, so we would have periods of higher activity. Also, depending on time of year, like maybe we're shipping more features towards a time like, the holiday season or New Year. So if we needed to scale up for situations like that, with our old provider, it was very challenging. It would take a while for them to manually basically set us up a new machine, and then we would spend several hours like manually installing a bunch of software. Yeah, exactly. So when we transitioned from that setup to our initial EC2 Mac setup, we still maintained like a static set of Macs. Like we would pick, when I joined, I think we had around 20 that we had set up from EC2. But already from that transition, we benefited from the AMI, right? So we just had to set up the image once, build it, and then whenever we provisioned a new instance through AWS, we could just launch that AMI.
So
onto
I
that.
stop you on that. An AMI, it's a disk image. So you prepare a disk image, you install all the tools, and that's a manual operation, I guess. And once you have your disk image ready, you capture a snapshot out of that, and then you can create additional virtual machines. Oh, with Mac, it's not really virtual machines; it's physical Macs, but based on that image. So your team maintain one AMI with the latest Xcode and the latest version of the tools that you need to run for the CI.
Yes, exactly. And we use Packer to generate that AMI, so we can actually capture as much of the configuration in code as possible. So, when I onboarded to the team, I could just look at that script and see, oh, okay, we're installing this tool, this tool, this tool. This is how we set up the image. And so that made it pretty easy to understand like what is actually in this Mac.
Yeah, and that's a pretty good practice as well, because you can version control this script, so you can see the difference between one Packer file and the next, and understand what changed there. What else beside the AMI?
What else in terms of
Infrastructure
what goes into
management?
it?
Yeah. How do you manage scaling, for example?
Yeah, so that was the next thing that we wanted to look into, was to see if we could leverage auto scaling, because obviously we don't really need machines on weekends that much. There might be a couple of builds running, but generally we can release most of the machines for the weekends. And again, our Wednesday release cut is the highest peak, exactly, and the rest of the week is slightly less. So we eventually managed to get auto scaling working with the EC2 Max as well.
The way you're
that was a
telling
big
it,
win.
it sounds like it was a bit painful. We eventually managed to get it working. So what was difficult?
From my perspective, I wasn't the one who worked on this directly. It was actually my old mentor, John, who now is working on a different team. But at the time, I think from my perspective, there were a lot of concepts to learn. Like it wasn't as simple as just, ticking a couple of boxes and saying we want auto scaling. I think when you have dedicated hosts, you need some form of way of allocating and deallocating those dedicated hosts automatically. And then the AWS auto scaling group itself has to connect to this thing called a host resource group, which is actually, creating and destroying those hosts as they're needed. And so I think it took a while for us to figure out how to set up the infrastructure like in a way that works, especially because we use Terraform to manage all of our infrastructure. So getting the Terraform working, it took a while to understand.
With license manager and the dedicated host, license manager is there just to count the host, even if there is no license to manage. And it was very early as well. At the time, I guess we didn't publish a lot of documentation. Now it's a more mature field. It's documented, and you're not the only one doing it. What is your scale? Typically, you go from like 1 or 2 machines during the weekend up to dozens of machines on Wednesdays?
Yeah, I would say sometimes we reach like 80 plus machines on a really busy Wednesday. And actually, one of the things that's changed recently in our build system, we used to run 2 builds in parallel on our EC2 Max, but our app has been growing incredibly fast over the past year. It's gotten to the point where having 2 builds running in parallel like causes too much strain on the machine, and sometimes it starts crashing or shutting down. And so we've switched back to using just 1 machine for 1 build. And so that's kind of increased the number of machines that we require, but it's also made our build more reliable and a little bit faster.
Are you building on x64 or Apple Silicon, the ARM architecture, or both?
We're using ARM and we love it. Especially going from M1 to M2, we saw some significant build time improvements of around 10 to 15% just for making that hardware change.
I'll go back at the end to the specific step you took to reduce the time. I think there are 4 or 5 very specific steps, but migrating to the latest generation of hardware is one of them, and using ARM. You said you were building the app on the two builds at the same time on the machine. How did you isolate the build? Was it running inside a like virtual machine on the machine, or just two set of process in two different directories?
Pretty much the latter. Just have two instances of Xcode running, and that did introduce a bunch of challenges because I think Xcode is not necessarily designed around that use case. So it makes a bunch of assumptions that, it's a developer making a build on their laptop. They probably don't have two things running at once. One of the weird things that we saw was Swift Package Manager has like a cache that it uses locally, and if you have two builds running at the same time, the cache, like the two Xcode processes, the two Swift PM processes start messing with the cache at the same time, and that can cause like packages to disappear, and Xcode freaks out. So we had to make a few tweaks to the setup to allow it to gracefully run two Xcode processes at once.
Yeah, I think these machines are designed for one user on our desktop, and maybe not the machine, but at least Xcode, as you mentioned, it's a desktop application. It has not been designed over the time to be a server application. How do you clean up the machines after a build to ensure that there is no artifacts left from the previous build, so that each machine is in a pristine state when you start to build? Do you restart them? Or?
That's a good question. I don't know that we do anything super sophisticated for that. I mean, the way our Jenkins agents are, the Jenkins agent configuration ensures that there's no, that within the Duolingo iOS repo, there's like, it basically gets rid of that directory after each build. So any of the build artifacts that are in there are going to be gone. There is sometimes some state changes that happen to like the system-wide Xcode directories.
Yeah, the caches that you mentioned.
Exactly. But actually, generally, it seems like we benefit from those caches. It makes it faster to install like Swift PM packages and things like that. So we haven't introduced any like scrubbing to make it super clean after each build.
And yeah, it might make sense to keep the cache. Actually, working on the cache is one way to increase or to decrease the time of the build, to increase the performance of a build. Are you taking any steps to proactively cache the Swift PM package, for example? That's the first candidate to cache on iOS, at least.
For the Swift PM packages, we just use the built-in caching mechanism of Swift PM. It seems to work pretty much the same as how it would work on my laptop. So that's been pretty painless.
Yeah, one of the advantage you have is you're always building the same app. You don't have to build multiple apps. So it's always you have one iOS app, and it's always, so it makes things a bit easier in terms of caching. You don't need to mix and match different apps.
Exactly, and I think the Xcode itself will do some local caching to make sure that the first build might take a while, but then the next build should be incremental and won't take as long. And so we do benefit from that. I don't know exactly how that caching works, so we haven't done anything sophisticated to leverage that. But one thing we did look into a while ago was remote caching. It's something that you can do with Gradle, for example. Gradle has like remote caching offering, but Xcode doesn't have any native functionality like that. We tried to make this open source project from Spotify called XC Remote Cache. We tried to make that work with our system, but we couldn't figure it out. And so it's something that we have in mind for the medium-term future, to kind of look into how we could benefit from remote caching. And I think part of that will require us to also continue modularizing our iOS app. That's an ongoing effort. But yeah, for the short term, I think we're happy with the amount of caching that we currently have just natively through Xcode.
To Xcode and the standard cache from Xcode. Something that many of our customers are struggling with, and it's not because of EC2 Mac, it's because of macOS and Xcode. It's the code signature, the threaded distribution certificate, developer certificate, mobile provisioning profile. How do you manage that? How do you ensure that the required keys are in the machine when it's time for signature?
Great question. And I think to add a little bit of context to how our release process works, we try to automate as much of it as possible. So yes, we have dedicated people that are on call each week to ensure that the release goes out. But in theory, 90% of that process is automated. So that includes the code signing. And so in order for that to be possible, as you said, we need to have those keys available on the machines to sign the app after it's built. So we use Fastlane Match to do that. And again, this was set up before my time, but I think I can give like a brief overview of how that works. We basically manually create the certificates and keys once a year or something like that. And then they get stored encrypted in a GitHub repo.
Private
GitHub repo, exactly. And then the machines have access to the decryption keys to download that stuff at build time, essentially.
Yeah, Fastlane it's a build system for mobile application that takes care of many steps, not only building, testing, but also taking screenshot. The screenshot to publish on the App Store can be automated there, and the key management and Match. It's that system from Fastlane that allows to store your key somewhere else, where all the build machine can fetch the key. You mentioned GitHub. They also support S3 and other storage repository, secure repository to store your keys. Are you using a Fastlane for your Android builds as well, or it's more based on Gradle?
I don't believe so. Sharanya, dude, I don't think so. Yeah.
No, we don't use Fastlane on Android. Yeah.
Because they advertise Fastlane as being the tool for Android and iOS. I only use Fastlane on iOS, but I was just asking the question. And so it's Fastlane taking care of downloading the keys, installing them at the correct location on the machine, and cleaning that location. Typically, it's the key store from macOS, cleaning it after the build. So actually, it's not a big challenge for you, or maybe there is one challenge that many customers have as well. EC2 Max machines are typically machines that runs without a graphical user interface, and to get the code signing works when there is no graphical user interface, it's a bit more challenging than when there is a graphical user interface, because the keychain is not unlocked and locked the same way. But did you add any challenge of that because of that? I don't know. I think Fastlane Match does pretty much the heavy lifting there, and you don't have to care about that.
Yeah. I think there is a way to unlock the keychain from the command line.
Yes.
So if I remember correctly, there's a step in our CI script that unlocks the keychain before doing any of the Fastlane stuff. So I think people smarter than me who were looking at it before me have already figured that part out.
I vaguely remember engineers doing whatever you mentioned, like about 4 years ago, manually. It's now lost in my memory, so it's been that.
That's good. If it is not an issue, then it's just something we can forget about, and we know the scripts are doing the right things, and that's one less thing to. Do you monitor the builds? How do you report errors for the developers? What if the build is broken? Is it because of the code? Is it because there is a problem in the infrastructure itself?
We do monitor builds, so I think there are it's a multifold process, right? Because we do want to ensure that the PR pipelines go smoothly, like this is before merge, and we also want to ensure that the on merge automation is intact. And then finally, like we also look at the release pipeline. So Mert was mentioning that we do have on-call rotation. So this is one unified rotation where we look at all things CI/CD. And this rotation is responsible for ensuring that, if things flake out, say, for example, tests, they do flake. Are they flaking for most of the flakes are for the wrong reasons. So, but there are some times that tests do fail for the right reasons, and we are quick to spot that as part of our notifications that we set up in our on-call channels. And the person on call would look at those alerts and would be like, hey, seems like we have a test that's failing for the right reasons, can someone take a look at it ASAP? And the sort of urgency goes as on Wednesdays, because at 3 o'clock Eastern time is when our cutoff is, and we want to ensure that bills stay green and that the lane to ship is pretty fast. And there is more precedence on like, okay, I'm going to revert because you are shipping something that's breaking and affecting the rest of the code. So on Wednesdays we do, like, the person on call actually makes that call and reverts at certain changes that go awry. And especially on Wednesdays, like, we also make a call, like saying, okay, sometimes it's just so many PRs, and it takes time for us to chew through that load. And we do guarantee that we ensure all the PRs that are supposed to be merged to get out in that release cut. So sometimes there is a bottleneck, and we say, okay, let's pause release, let's make sure all the PRs get in, so that we can actually get all those PRs into the release. So these are the types of responses that usually the on-call person on call is responsible for, and pretty it's working pretty well so far. And there are days when we forget that it's a Wednesday because everything is going very, very smooth. And we're like, oh, wait, do we remember that this is happening? And then we suddenly see a mail from our automated systems saying that the release has already been cut and it's ready for our dog fooding, which is such a game changer.
And the upload to the stores, it's done automatically as well. Once all has been approved and tested, you have scripts to automate.
It's all on test flight. So, of course, with test flight, you have a couple of caveats. You need to keep your phone charged for it to upload, upgrade the latest.
Mm-hmm.
But once when we push the latest on test flight, it's automatically distributed.
And so your beta testers have the new version of the app, and then I guess there is a human in the loop to decide, okay, that build will be promoted to the App Store for all the users. There is still some manual steps there. I have a naive questions because I never worked in a platform engineering team. How do you manage the artifact? You talk about hundreds of builds. These hundreds of builds are generates hundreds of binary files, IPA file probably in the case of iOS. How do you match a specific IPA file with a specific build, pull requests? How much code is in there? What version it is? And where do you archive them? Do you archive them? So sorry, it's a lot of questions, but how does it work?
So, great question. So I'll start by saying on iOS, we don't actually automatically build the app for every single commit, because
just
the full app build. We only compile what we need for the tests. And then we actually build the app after it's merged. And we do automatically build every commit once it's merged, once the PR is merged, and those builds are stored in S3, just keyed by their commit hash.
Okay.
We do also provide developers another way of generating builds while they're iterating on their features. We have a Slack bot that we call the iOS build bot, which seems to be an easy way for most of our developers to be able to generate a build without necessarily having to interact with Jenkins. A lot of product engineers are not super familiar with the infra side of things, so we just try to make it easy doing it over Slack. So they will request a build on a certain branch, and then a couple minutes later, 10 to 15 minutes later, they should receive a message saying, hey, your build is ready.
I was looking at the blog post that you published a few months ago. I think it was in December last year, and you two helped to co-author that blog post where you explained how you went from 50-minute build time to 16 minutes. And I think basically we talk about everything. Use the latest generation of hardware when it's available. Try to use more parallel builds, improve caching, toolchain upgrades. We didn't talk about that. What is a toolchain upgrade? You call that the spring cleaning.
Oh, so you're talking about toolchain upgrades. We didn't do much on the iOS side. This was mostly on the Android side where we said, we will not use Kotlin annotation processing anymore and embraced KSP, which was faster and sleeker. And yeah, so that change got us a lot of build time improvements on Android side, but not necessarily anything that we could call in our podcast about iOS CI.
Okay, no, I understand better. That's why I didn't understand that point in the blog post. It's because it was on Android. There is a mystery in your blog post. The build time are roughly equivalent on Android and iOS. It's not the same code base. It's not the same tool. It's not the same machine. It's not. Do you have any explanation why at 1 minute close you are at the same build time both before optimization and after optimization on both platforms? That's surprising, no?
That is surprising. We did not set it out to that goal. We actually wanted things to be under 10 minutes. It was very ambitious. But I think at the end of the day, we realized that modularization is going to be like super impactful in terms of like how we can cache things and how we can like leverage remote caching even more effectively. Yes, but to your point of like that
it's
is
just by chance.
Like it's coincidence, but it's not something that we planned for. But our original goal was to be more tight. But yeah, I think like Mert had mentioned, like the midterm goal is to like actually go back and speed up our modularization efforts, and so we can leverage something like Bazel for iOS and see how that works.
So Bazel is the build system from Google, I think, or from
Yes.
Meta? No, from Google. The learning curve is huge. So, but that's a good segue. My next question was, okay, now you're there, you significantly improve the performance of your CI, you gain more confidence about your build and your ability to scale your fleet as well, both on Linux and on macOS. So what's next? What are the next challenge you're ready to tackle, or the next business requirement that you need to implement at the CI level?
So the fun fact is the TRI team or the test and release infrastructure team does not exist anymore. So
the platform will continue to live by its own.
there is a CI/CD team right now,
Okay.
and they are looking into reducing flakes. Flakes is something that is definitely a painful experience for our developers. So imagine the number of times that you are retrying within the test suite level and also like at the infrastructure level. So say, for example, for some reason, git clone doesn't work. I mean, like cloning doesn't work as expected. And so, or there is a GitHub outage or things like that can still affect. How can we make it more foolproof and like keep our retries or reruns pretty fast, or even like get to the point of no reruns? So that is like the next goal for the CI/CD team. And we do have another team that is client architecture team where they are looking into modularization, as I mentioned, as like the next phase of improving things.
So modularization, if I understand well, it's to create an app which is made of different modules that would allow to recompile just one module when there is a change on that module and not the entire code base. That's the idea?
Yeah, that is.
So modular, it's difficult for me to pronounce making it more modular and working on having a CI chain which is more resilient to external challenge that you might have. You mentioned like an external provider which is not responding at the moment of the build. That's a two key team on which they are working on right now.
One of the recent improvements that we made to the image building experience, we used to have this problem where in order to download and install Xcode, we would have to do it from the Apple website. And in order to do that, you actually need to be logged in. So whoever was building the image would have to like go and manually log into the Apple website, copy and paste a cookie
and
I
know there is a solution for that, but I'll let you continue.
Instead of doing that every time the image is built, we just do that once manually, copy it into S3, and then that way we can download it without having to authenticate. using a cookie. Yeah, so that was a nice improvement.
What else are you are you looking at?
Yeah, another thing about the image building. So I have there's been a couple of stories of challenges that have happened because of lack of dependency pinning. So the AMI build script that we have, it just has a bunch of brew install commands to install a bunch of different packages, but we didn't actually ever set it up so that those were pinned to specific versions. So I remember during one of the image upgrades, we had this situation where the CA certificates package, for some reason, something happened upstream where the version upgraded and it didn't work anymore. Everything stopped working. We couldn't do Git operations. We couldn't pull anything from the cloud on that new image. So that took a while to debug. But that is something that we could look into, is to make things more reproducible by pinning the dependencies to specific versions.
Or to have a local cache of the brew repositories, for example. Are you looking at managed AWS services and thinking about code artifact to store a Swift package or Kotlin package inside your AWS account? I'm thinking about code build that can also orchestrate and manage the scaling of your fleet automatically, so you don't have to allocate the dedicated host by yourself. Is it something on your radar, or not at all? You're just happy with the current setup as it is?
Yeah, I don't think those things are on our radar right now. And honestly, I think, as Sharanya kind of alluded to, I think the overall system is pretty stable now compared to where it was a couple of years ago, to the point where we were able to step away from having a dedicated team looking into client-side CI. All things considered, things are great.
That's a great conclusion. Anything to add?
Oh, just wanted to give a huge shout out to a couple of people at AWS who helped us navigate all of the challenges that we listed out. So it's Brent and Vishal. Vishal, who's the product manager, and Brent is our TAM. And Brent comes in every week at the Pittsburgh office, and so we were able to leverage his office hours. And Vishal was almost always available on Slack with us, and so all of these communication touch points really helped us stay connected and move fast.
Yes, I suspect Vishal to have a hands on Slack on his iPhone on one hand and working on the other hand, because he's always super responsive on Slack, even internally. I'll pass the message. Thank you both of you for explaining the CI/CD chain and the platform engineering aspect at Duolingo for this app that you are probably using if you're learning a new language, or no, you can also learn math things with Duolingo. Give it a try. It's available on Android and on iOS. Sharanya Viswanath, your senior engineering manager, and Murtaza Javait, software engineers as well. Thank you for your explanation, super clear about your CI/CD platform. Thank you for having listened this episode until the end. See you next week in all good podcast application. But now, go build.